Now in this lecture we are going to implement fractional knapsack problem in practice. Now here the first thing that I'm going to do, I'm going to create a separate class for knapsack item. So in this class we are going to have the properties of knapsack item, which are index of the item, value of the item, weight of the item, and ratio of the item. So here I'm just going to create a new file and name it knapsack item.java. Then inside this file, I'm going to declare our class like this: public class knapsack item. Then here I'm going to declare the properties of the knapsack item. So here the first property will be private int index. So this will be the index of the item. Then we will have private int value, so which will be the value of the knapsack item. And then we will have private int weight. So this will be the weight of the knapsack item. Then we will have another property which will be the type of double. In this case it's going to be ratio. So ratio will be calculated based on the weight and value. Then inside constructor I'm going to initialize these properties over here based on the parameters that we get from the user. So it's going to be like this: public knapsack item. So as a parameter, as a first parameter it will take index. So this will be the type of integer. Then integer type for value, then integer type for weight. And we are not getting the ratio from the user because we are going to calculate it based on the value and weight. So in this case it's going to be like this: this index is equal to index that we get from user, then this value is equal to value that we get from user, and this weight is equal to weight that we get from user. Then ratio will be equal to value multiply 1.0 divided by weight. So with this we have successfully implemented our knapsack item class over here. Now here again I'm going to implement helper functions for getting and setting these properties over here. Now the first function will be public int. This will return the type of integer, will be responsible for getting index. So here we are just going to return index, and then the second method will be responsible for setting the index. So it's going to be like this: public void set index. So in this case it's going to take as a parameter integer type of index, and inside this method we are going to set index. This index is equal to index. Then I'm just going to copy this method from here and pass it over here, and I'm going to change them for value and for weight. So it's going to be like this: get value is going to return the value, and set value will set the value. Set value, so the parameter is going to be value. So here also we are going to change it like this: this value is equal to value. So one more time I'm just going to copy it from here and pass it over here. So we are going to change it for weight. Get weight, so it's going to return the weight, and set weight. So this one also is the type of integer, and we are just going to set weight like this. Then I need to create two more functions for getting the ratio and setting the ratio. So it's going to be like this. So here again I'm just going to copy these methods from here and pass it over here. So in this case we are going to change it get ratio. So it's going to return the ratio, and set ratio. So as a parameter it will take the type of double, because as we said before the ratio is the type of double. So we are just going to set ratio like this: this ratio is equal to ratio. Now then at the end, for printing out the knapsack item to the console, I'm going to override the toString method. So it's going to be like this: override public string toString. So whenever we are going to call the print function for this knapsack item, is going to return this expression that we are going to write over here. So I'm going to write something like this: item index is equal to, so we are going to concatenate it with index. Then I'm going to put the value like this: value is equal to, then we are going to concatenate it value. Then we are going to put weight is equal to, so we are going to concatenate it weight. Then at the end we are going to put ratio is equal to plus ratio. So with this we have successfully overridden the toString method over here. So with these helper methods over here we have finished our knapsack item class. Now after finishing the knapsack item class, we are going to implement fractional knapsack problem inside separate class which is called fractional knapsack class. So here for this method I'm just going to create a separate class. So that's why I'm just going to create a new class for fractional knapsack problem. So I'm going to name it fractional knapsack.java. So here I'm going to create the class for solving the fractional knapsack problem. So the first thing that I'm going to do, I'm going to import Java util library, because here we are going to use the collections and array list. So in this case it's going to be .star. Then I'm going to create our class like this, public class fractional knapsack. Then inside this class I'm going to declare our method like this. So this method is responsible for solving fractional knapsack problem. So it's going to be like this, static void. So the name of method will be knapsack, and as a parameter this method will take two parameters. So the first parameter will be the array list of knapsack items, and the second parameter will be the capacity. So in this case it's going to be like this, array list. So the first parameter is the type of array list with knapsack item. So I'm going to name it items, and the second parameter will be the type of integer with the capacity. So as we said before, the first step over here is we need to sort the items by their ratio. So to sort the items by their ratio, we need to implement comparator on these knapsack items to compare the items based on their ratio. So in this case, I'm going to create a comparator like this. So comparator with the type of knapsack item, and I'm going to name it comparator, is equal to new comparator with the type of knapsack item like this. Then here I'm going to override the compare function. So we are going to override it to compare the items based on their ratio in descending order. So it's going to be like this, public int compare. So the first parameter will be type of knapsack item 01, and the second parameter also will be the type of knapsack item with 02, because here we are comparing two items over here. So here I'm going to put like this, if 02 get ratio is greater than 01 get ratio, in this case I'm going to return 1, otherwise we are going to return -1. So with this we are implementing a logic in which we are going to sort the knapsack items based on their ratio in descending order. So after doing so, we are going to use the collections to sort the knapsack items over here. So after comparator over here, I'm just going to call collections.sort. So it's going to take two parameter, items and comparator. So in this case, it's going to sort them based on their ratio in ascending order. Now after sorting them, we are going to continue to run our grid algorithm. So in this case here, the first thing that I'm going to do, I'm going to create used capacity with the type of integer. So initially we are going to set it to 0 because initially we have not used any capacity, and I'm going to create type of double for total value. Total value is equal to 0, and then we are going to loop through the items one by one and check that if full consumption possible, then we are going to consume it. Otherwise, we are going to consume it fractionally. So it's going to be like this. For knapsack item in items, we are going to check that if used capacity plus item dot get weight, so with this we are getting the weight of the item, is less and equal to capacity. In this case, we are going to add item weight to the used capacity, and we are going to add the item value to the total value. So it's going to be like this. Used capacity plus item dot get weight. Then we are going to print out this item to the console saying that this item is taken. So system out println. So I'm just going to put like this, taken concatenate with item. Then I'm going to add the value of this item to the total value. So total value will be plus item dot get value. So in this case we have created total value with the type of double, because in this case we are going to add some fractional amount to this total value. That's why we have taken it as a double value. Now otherwise, if that's not the case, we are going to consume the value fractionally. So in this case, I'm going to create a new variable over here, which will be used weight. So this used weight will be equal to capacity minus used capacity. So then we are going to create the type of double as a value, and it's going to equal item dot get ratio multiplied by used weight. Then we are going to take as a weight used weight and as a value the value that we have calculated over here. Now before increasing the used capacity and the total value by using this used weight and value over here, I'm just going to print out to the console obtained value and used weight. So it's going to be like this: system.out.println. So here we are going to put taken, so it's going to be item index is equal to, we are going to put item.getIndex. Then we are going to concatenate obtained value is equal to, we are going to put the value that we have calculated over here. Then we are going to concatenate it one more time, used weight is equal to, so we are going to concatenate used weight. Then at the end we are going to concatenate it with the ratio. So it's going to be like this: ratio is equal to item, so we are going to concatenate it item.get ratio. Then we are going to increase the used capacity with the used weight. So it's going to be like this: used capacity plus used weight, and total value will be increased with the value that we have calculated over here. Now at the end, to break out from this loop over here, we are going to check that if used capacity is equal to capacity, this means that it's full, so we are going to put over here break. Then after this loop over here, I'm just going to print out to the console the total value that we have obtained. So it's going to be like this: system out print total value obtained. So we are going to concatenate it with the total value that we have obtained over here. Now with this, we have successfully implemented our method over here. Now let's see how this method works in practice. Now here inside main method, I'm just going to create the array list with the knapsack items, and we are going to set the value and weight of these items over here. So it's going to be like this: array list with the type of knapsack items is equal to new array list, like this. Then I'm going to create another integer type of array over here for values. So in this case we are going to set the values that we have in our previous lecture. So as you remember, in the first box we have the value of 100, in the second box we have value of 120, and in the third box we had value of 60. And the weight of this box was like this: weight is equal to, so the first box weight 20, the second box weight is 30, and the last box weight was 10, and then the capacity was 50. So based on these two arrays over here, I'm just going to create the items and add these items to this items array list that we created over here. So it's going to be like this: for it I starts from 0 and it continues until the end of the value dot length, and in each time it's increased by 1. Then here I'm going to call items dot add, so new knapsack item. So I'm going to put over here I plus 1 because index starts from 0. In this case we are putting it to start from the 1. So I'm going to take as a value I, as a weight we are going to take it from the weight array that we declared over here. So with this we have successfully created knapsack items and we have inserted them into this array list over here. So I'm going to call knapsack problem for these items with the capacity of 50 over here. So it's going to be like this: fractional knapsack dot knapsack items and capacity. So if I run our code, now after running our code, you see that we have an error over here with the conversion of double to integer. So inside knapsack item class, here we have put as a return type integer, but we are returning double. So in this case we need to change it to double over here. So after changing it, if I run our code one more time, you see that in this case it's printing out the solution to the console. So in this case you see that first it's taken the item with the index of 3, in which we have the value of 60 with the weight of 10, and the ratio is 6. So you see that the ratio is the greatest one. Then we have taken the item with the index of 1, in which we have the value of 100 and the weight is 20, so the ratio is 5. Then at the end we have taken the item with the index of 2. In this case we have taken only the fractional value, which is the 80, and the ratio is in this case 4 and the weight is 20. So as you can see, at the end we have get the maximum value over here, which is 240. So this is the value that we got when we are discussing the algorithm of fractional knapsack problem. So with this, we have implemented a class for fractional knapsack method successfully. Now let's see what's the time and space complexity for this method over here. So as always, we are going to start from the first line of code. Now in the first line, we have created a comparator in which we have override the compare method for comparing the items based on their ratios. So this creation of comparator over here will take O1 time complexity. Then we have sort algorithm over here. So in this case, if we are using the collection sort method, in this case it takes O(n log n) time complexity. Then we have created use capacity and total value over here. So in this case, these two lines of code will take O1 time complexity. Then we have a loop over here. So inside this loop, we have if conditions. So based on if conditions, we are increasing the use capacity or total value, and we are printing out some message to the console. So it's obvious that this if conditions will take O1 time complexity, but the loop itself will take O(n) time complexity, because in this case, it has to loop through all elements of the items that we have in this array list over here. If the number of items is n, so in this case, it's going to take O(n) time complexity. Now then, after this if conditions over here, we have another if condition over here, which is for breaking the loop. So in this case, if the used capacity is equal to capacity, in this case, we are breaking the loop. So this will take O1 time complexity. Then at the end, we are printing out to the console total obtained value. So this one also will take O1 time complexity. Now if we combine all these complexities over here, it will take O(n log n) time complexity. Now for this implementation, space complexity will be O1, because in this case, an extra memory is not required to perform this method over here. But if we are going to return the array of the items that we have taken, in this case, it's going to take O(n) space complexity. So with this, we have come to the end of this lecture. So in this lecture, we have implemented a method for solving fractional knapsack problem. So hopefully everything is clear about this method. So see you in the next lecture.